Hello. Alright, so the purpose of this video is to kind of show you how this quotient property of square roots rule works. Okay, so we'll use this product property in some shape or form, but basically we're going to focus on the quotient property. Okay, so quotient property basically says the square root of some sort of fraction is going to equal basically the square root of the numerator divided by square root of the denominator. Okay, so an example here is something like, well, if you have the square root of 5 over 9, so that's the same thing as square root of 5 divided by square root of 9, and that equals the square root of 5 divided by 3. Okay. Um, Now, what you could do actually, in most cases actually, yeah, so if you didn't see this here, so square root of 9 is basically the same as 3. So in most cases actually, I probably won't give you a nice square root, but let's say you didn't realize that the square root of 9 is 3. One way that you could break it up, so this is basically square root of 5 divided by square root of 9. Okay, generally what you want to do when your goal is actually to write this expression in simplest radical form. So in order to write this expression in simplest radical form, there should be no radicals or square roots in the denominator. So one way we can get rid of that is basically we can multiply top and bottom by square root of 9. So we're going to use this product property here. So we have square root of 5 times square root of 9 is square root of 45. Then come down here. So square root of 9 times square root of 9, we can actually do a little shortcut. So square root of 9 times square root of 9 is basically square root of 81. And square root of 81 is 9. Or what you could do is basically, since you see that they're the same, basically this is the same thing as the square root of 9 squared. And what's going to happen actually, basically the square root is going to cancel out with the square. You get 9. So a couple different ways that you go about doing it. Yeah, but basically this is 9. The shortcut here is basically when you have a pattern like this, then you can rewrite it like that. 45 breaks up into 9 and 5. 9 breaks up into 3 and 5. So what we have here, this is 3 and 3. And then what we have is square root of 45 equals the square root of 3 times 3 times 5. So what we have is we have our partners in crime. One gets shot, one comes out. So 3 times square root of 5. So 3 times square root of 5 divided by 9. So this cancels, we get 1/3. So we get square root of 5 divided by 3, as you can see here. Okay, so as you can see, we got the same thing as what we got there. We got the same thing as what we got there. All right. Let's try to do an example. So, okay. So, for each of these examples here, so we're gonna write each expression in simplest radical form. So simplest radical form. So that is generally what we're doing for these problems. Okay. So what I have is, let's start off with square root of 3 divided by 20. Okay, so generally if you use that quotient property, we can actually manipulate this. So we can rewrite it as square root of 3 divided by square root of 20. Then what we can do next is we can actually get rid of the square root denominator, but we have to multiply top and bottom by square root of 20. So by doing so, we have square root of 3 times square root of 20. So we need to just multiply right across. So we have square root of 60. Then square root of 20 times square root of 20, like I showed you earlier. As you can see, if you put them together, this is basically going to be the square root of 20 squared. So basically the square root will cancel out with the square, and all you're left with is 20. In other words, what you could do, the little shortcut, is if you see a pattern like this, you can just write 20. Okay, next, so square root of 60, when you break this up, 60 breaks up into 15 and 4. 15 breaks up into 3 and 5. And then 3 and 5, 4 and 4 breaks up into 2 and 2. So square root of 60, same thing as square root of 3 times 5 times 2 times 2. 1 gets shot, 1 comes out. 2 times square root of 3 times 5, which is 15. So when we reduce this, this is basically 2 times the square root of 15 divided by 20. Then what we can do is 2 over 20 here can reduce. So 2 over 20 reduces to 1 over 10. And what we're left with is the square root of 15 divided by 10. All right, so that's basically how that first type of problem works. Okay, I'm going to show you a different example. Okay, so let's say I gave you something like this. Okay, so I'm going to go ahead and clear the screen actually. So all the questions are asking the same thing. Square root of 8 divided by 15. Okay, so generally what we want to do is we're going to go ahead and write this. This is square root of 8 divided by square root of 15. So couple ways you could do this. You could actually break up square root of 18 if you want. If you see it's 2 square root of 2, then you can multiply top and bottom by square root of 15. You can do that as well. Or what you can do is just keep things simple. You want to get rid of the square root of 15 in the denominator, so multiply top and bottom by square root of 15. So square root of 8 times square root of 15 is going to be square root of 120. Square root of 15 times square root of 15 is going to be 15. Okay, 120. 120 breaks down into 60 and 2. 60 breaks up into 30 and 2. This is 5 and 6. And then this is going to be 3 and 2. So what we have is the square root of 120. Same thing as the square root of 5 times 3 times 2 times 2 times 2. Okay. 15, 30. Okay, and then what we are going to do is we look for partners in crime. Partners in crime, one gets shot, one comes out. 2 times the square root of 5 times 3 times 2. So we have 2 times the square root of 30. So we can change this as 2 times the square root of 30 divided by 15. And I believe that's it. I believe we can't simplify it any further. So this would be in simplest radical form. Okay, let me show you another example. Okay, so let's say I gave you something like 6 divided by square root of 3. So same idea. We're going to get rid of the square in the denominator, multiply top and bottom by square root of 3. So this is basically 6 times square root of 3 divided by, again, what I told you earlier. Whenever you have a pattern that looks like this, square root will cancel out with the square, and then you're going to have 3. So what we have it on the bottom is just going to be 3. 6 over 3 will reduce, as you can see here. This will reduce to 2 over 1. So we just have 2 square root of 3. That's how that one works. Okay, let's go ahead and show you another problem. Let's say I have 16 divided by square root of 2. Okay, 16 divided by square root of 2. What we have is we can multiply top and bottom by square root of 2. So what we have is this is, so 16 times square root of 2. So that doesn't change, 16 times square root of 2. If you guys have seen a little pattern recently what I showed you, basically this is going to be 2 because this is square root of 2 squared. Square cancel with the square root cancel with the square, and you're left with 2. Okay, 16 divided by 2. This will reduce. This will reduce to 8 over 1. So this is basically 8 square root 2. All right, so that's basically how that one works. All right, so let's go ahead and do another example. Let's say I gave you something like 3 divided by square root of 8. All right, 3 divided by square root of 8. So what I see here, basically I can multiply top and bottom by square root of 8. So what I have here, so I just multiply across 3 times the square root of 8. And then I take this here, is going to be 8. Okay, so what I see is 8 can actually be reduced. 8 can be changed. So 8 is 2 and 4. 4 breaks up into 2 and 2. Square root of 8, same thing as square root of 2 times 2 times 2. All right, so we're looking for partners in crime. One of them gets shot, one comes out. 2 times square root of 2. So we have 3 times 2 times the square root of 2 divided by 8. Now, in order to simplify this, we have this number and this number here. So we're going to go ahead and multiply them together. So we have 3 times 2 is 6. So 6 times square root of 2 divided by 8. All right. Okay, so that covers those problems. I'm going to stop this right now, and I'll continue where we left off. Okay, that. Aha. Okay, so as you can see here, as you can see right over here, right? I made little, I just forgot to reduce. So this is 3 over 4. So actually this is 3 times square root 2 divided by 4. All right, so that is how you would reduce that one. Okay, I'm gonna go ahead and clear the screen, show you a different example. Okay, so next one, so square root of 7 over 3. So 7 over 3 reduce, this changes to square root of 7 divided by square root of 3. Then we're going to multiply top and bottom. We can actually multiply top and bottom by square root of 3. So this is square root of 21 divided by 3. 21 breaks up into 7 and 3. So what that means is basically we're done here. I don't think that can be simplified any further. All right. Next example. Okay. Square root of 45 divided by 2. So when we look at something like this, we get square root of 45 divided by square root of 2. Okay, so interesting things that happen here. Multiply top and bottom by square root of 2. So this is square root of 90 divided by square root of 2 times square root of 2 is going to be 2. Then 90 breaks up into 10 and 9. 9 breaks up into 3 and 3. So we have 3 times the square root of 10 divided by 2. So if you guys have kind of seen the pattern, yeah, that's basically how that one would change. Okay, let me see. I think that's all for now. Okay, so that's good. Now I'm going to go ahead and go through some other examples. Okay, so I'm going to show you just a few more examples, how this connects to the completing the square examples that we've done previously. Okay, x squared plus 5x equals negative 3. Okay, so what you could do is basically this breaks up. So this is basically x squared plus 5x. And then if you take their b term, so b divided by 2 and square it, so this would be 5 over 2 squared if we're basically completing the square. Then this is going to be negative 3 plus, and then we have 5 over 2 squared. So if you guys remember, if you take 5 over 2 squared, this is the same thing as 25 over 4. So this is the reason why, like, when you do these types of problems, by completing the square, it's probably not recommended that you do it this way because you get some ugly fractions. Again, what I'd probably recommend that you would do is you just use quadratic formula for this. But now that I've shown you that other way, I can go ahead and show you that. So now what we could do actually, so this expression, if some of you have kind of seen a pattern when we completed the square, it always breaks down to something of this form. So whatever your b term is, you're dividing it by 2. So we can actually change this. This is x plus 5 over 2 squared, and this equals, we can change this with the common denominator of 4. So this is negative 12 divided by 4 plus 25 divided by 4. And we have x plus 5 over 2 squared equals negative 12 plus 25 is going to be 13 over 4. Then what we can do is we can go ahead and take square root. So we take the square root of both sides here. Square root cancel with the square. We get x plus 5 over 2 equals. Then what we can do is we can actually break this up. So this is where that little rule comes in earlier. This is square root of 13 divided by square root of 4. Square root of 4 actually breaks down, right? Square root of 4 is 2. So this is square root of 13 divided by 2. Oops, I forgot my plus minus. Don't forget the plus minus. Then what we can do is we can subtract 5 halves on both sides. So I'm running out of room here. I'm just going to write this here. X plus 5 over 2 equals plus or minus square root of 13 divided by 2. So I'm just going to subtract 5 over 2 from both sides. So you get x equals to negative 5 over 2 plus or minus square root of 13 divided by 2. And as you could see, this is basically x. So it's negative 5 over 2 plus square root of 13 divided by 2, or negative 5 over 2 minus square root of 13 divided by 2. So yeah, so that is how you would do something like that. And you can go ahead and check that this should work out if you decided to use quadratic formula as well. Okay, now I'm going to just show you a different example. So different example here. So let's say I gave you something like this. So x minus 4 squared, and this equals 25 over 3. So rather than starting all the way from the beginning with that completing the square part, let's just focus on just a quotient property. Okay, so we have a square here. In order to get rid of the square, we need to take a square root. So when you take a square root of both sides, square root cancel with the square. X minus 4 equals, and then this is where it gets a little bit interesting. So square root of 25 over 3 is the same thing as the square root of 25 divided by square root of 3. Now, a couple ways you could do this. If you see the square root of 25 is 5, you could actually break that down. So x minus 4 equals 5 divided by square root of 3. Now, what we can do is we can go ahead and we can change this. We don't want square roots in the denominator, so we have to multiply top and bottom by square root of 3. Okay, so we multiply top and bottom by square root of 3. We get x minus 4 equals, so this is this multiplies right across, 5 times the square root of 3. And divided by square root of 3 times square root of 3 is 3. Don't forget the plus minus. I seem to have forgotten whenever you take a square root, don't forget the plus minus as you come down. And then what you want to do is you want to add 4. When you add 4, this cancels, get x equals 4 plus or minus 5 times square root of 3 divided by 3. So yeah, that's basically how that one would look like. Okay, I'm going to go ahead and clear the screen. Okay, and then sometimes you get something like this. So x plus 6 squared, and this equals 11 over 5. Okay, so what you could do, again, you want to get rid of the square here. You want to solve for x, so take square root. Take square root of both sides, square root cancel with the square. X plus 6 equals, we can break this up, square 11 over 5, same thing as the square root of 11 divided by square root of 5. So what we want to do is we want to get rid of the square in the denominator. So in order to do that, we can multiply top and bottom by square root of 5. Then what we have is x plus 6 equals, we can multiply straight across, square root of 11 times square root of 5 is square root of 55. Then multiply across here. Again, if you guys have seen the pattern, this is 5. Do not forget the plus minus when you take the square root. Then you can subtract 6. Subtract 6, we have x equals negative 6 plus or minus square root of 55 divided by 5. So as you can see, that would be how you would solve for x given something like that. Okay, so that is how that works. Let me show you that other problem. I still have quite a bit of time. I just realized I forgot to show you. So x minus 4 squared equals 25 over 3. So another way that you could do it, like I mentioned, take square root of both sides. Get x minus 4 equals, and then what you have is square root of 25 divided by square root of 3. Okay, so if you didn't see earlier that, yeah, so what you could do is, if you didn't realize square root of 25 was 5, you could multiply top and bottom by square root of 3. So you get x minus 4 equals, square root of 25 times square root of 3 is going to be square root of 75. Oh, there we go. And then this is square root of 3 times square root of 3 is going to be 3. And then what we have is we can break up 75. 75 breaks up into 25 and 3. 25 breaks up into 5 and 5. So x minus 4 equals, so this is 5 times the square root of 3 divided by 3. And then similarly, just like the other problem, we can add 4 to both sides. And then as you can see, what we get is going to be something like x equals 4 plus or minus, so 5 times square root of 3 divided by 3. Yep, don't forget the plus minus. My bad, I just seem to have kept forgetting, but that is basically how that works. Okay, please let me know if you have any questions on this, and that is it. Okay.